All right, we're going to take on one that's a little bit tougher now. So this is what we call a mathematical proof. This is 1.4, number 24. So my goal is to challenge you a little bit. One reminder on any of this stuff, if you look in the front matter of your textbook, you'll find a lot of these things as kind of givens in the front matter of your textbook. Some of the identities and the reciprocal properties of trigonometric functions. So it's in the front matter of your textbook, including the unit circle with all the points on the unit circle. I'll actually give you some of those things for the quiz next week, so don't feel like you've got to memorize those. They'll actually be in the front matter of the quiz. So what we want to do here is we want to prove that the sine of theta over the cosecant theta plus the cosine theta over the secant theta is equal to 1. So if we add those two results together, we should be equal to 1. So first of all, sine of theta can again always be rewritten as y over r, if you remember that from our lecture. And cosecant theta can always be written as the opposite of that, or the inverse of that, of r over y. So sine of theta always works with the y term, and cosecant is just the inverse of that. And we're going to add that to the cosine theta, which is again x over r, and then the inverse, which is the secant theta, which is r over x. Okay, so now you might be saying, well, that doesn't seem to help me a whole lot, but it actually does, because what you're going to be able to find right now is this actually makes your life a little bit easier. So anytime I see sine of theta, I ask myself, how can I rewrite this thing? Well, y over r, cosecant theta, r over y, and so on and so forth. When I take this and divide it by this, it's the same as multiplying by the reciprocal, so I get y over r times the reciprocal of r over y, which is y over r again. So those two are going to multiply. I'm going to add that to x over r, and then the reciprocal of r over x, which is x over r again. Okay, so now we've got some numbers here that you might say, okay, well, this doesn't look quite so bad. What we get for this first term over here is y squared over r squared plus x squared over r squared. And again, you might be thinking, well, it seems close. I'm not sure. So I'm gonna go down here now a little ways and say, well, these have a common denominator, so I could write that as, I'm going to reverse the terms here too, x squared plus y squared over r squared. Okay, I still haven't shown 1. However, I recognize this guy right here. If I take the unit circle again, okay, if I draw the unit circle where I have an x term and I have a y term, and the unit circle looks like this, and I draw a right triangle in there, just like that, with a radius r. Okay. The first thing to notice is that radius r, by Pythagorean's theorem, is r would be equal to the square root of x squared, using this x term here, plus y squared. Well, you might say, well, why is that? Well, the reason why that is because a squared plus b squared equals c squared by Pythagorean's theorem. So that this is a squared plus b squared equals c squared. Therefore, c, or in my case r, the hypotenuse, is equal to the square root of a squared plus b squared, which again in my case is x and y. And you might say, okay, well, that's kind of cool. It's also worth mentioning that if this is true, then isn't it also true that if I square both sides, r squared equals x squared plus y squared? Isn't that also true? Square this, you get rid of the radical, right? So that means that I can actually replace, any place I see x plus y squared, it could be replaced by an r squared. So now I have r squared over r squared, which obviously is equal to 1. That is a mathematical proof. And again, you may have to utilize some additional tools. You may want to go back and look at the front matter. You may want to you know, when you're doing a proof like this, you're really looking for any way that you may be able to rewrite this and say, well, is there a different way I can rewrite this? So I know I can rewrite it like this. And then can I manipulate that so I get something like this that turns into something like this, so on and so forth.